Okay, hi guys. First, I'm recording on my iPad, so that's why I keep looking from there to there because my camera's over there and I'm over here. So if you get annoyed from me looking back and forth, really sorry. I want to get on here because one, long time no see. My hair is much longer now. Haven't been able to get it cut. And I wanted to say that how disappointed I am about our year ending like it will. This is not how I expected this year to go. I was kind of hopeful that we would have a chance to come back and at least have like 1 or 2 days left of school, even if they would just be like us hanging out and not really doing much school. But I don't know. I think at the end of our last week of school, I'm really just gonna focus on getting more time for us to actually meet face to face. So more Zoom meetings and less content stuff because I missed out on the last part of school. So and so did you guys. So be looking forward to that. And the other thing is I just got done editing the video that you're about to watch, and I realized that I don't know what day it is. I thought it was Tuesday. And so in the video, I talk about how there's going to be another video before Friday, and that's not true because today's Wednesday, but you're watching this on Thursday. So that means tomorrow is Friday. So on Friday, we are going to do a quizzes live, and the way that's going to work is I'm going to have a link for each class period, and you can join during your class period, or you can join during a different class period. Now, that being said, when you join, you have to use your full real name. If you use anything other than your real name, I'm gonna kick you out, and you won't be able to play. So, the reason why we're doing quizzes is it's something different. It'll be a little bit more fun than just taking a boring quiz on Canvas. So, it'll still be worth points. I'll have to figure out how to scale it, how to grade it, but yeah. So quizzes live on Friday. If you want to join during class period, cool. I know a lot of teachers are very strict on when they have classes, so I'm not going to be as strict. But if you want to join during your regular class or your not regular class, up to you. But use your real name, okay? I think that's it. But yeah. This is my fourth time taking the video, and I'm just gonna leave that in there because I'm tired of cutting and having blooper reels. So yeah, hope you guys make it through this next video and turn in your assignment today. Alright guys, welcome back. I know yesterday's homework was pretty difficult, so if you got at least one of those right, just give yourself a pat on the back because these were hard. So the first part of this is me going to go over those 4 problems, and then I have a few more problems that are a little bit easier, that I think will just reinforce these ideas a little bit better than the problems I used yesterday. So for your assignment today, you're going to turn in your corrections to any of the problems that you might have missed on the attendance quiz yesterday. The rest of these problems that I'm going to do are just going to be extra help if you need it, because the idea that I am going with right now, I keep changing my plans for this week. I don't know why, but things just keep popping up. And as of right now, I'm planning on doing a quizzes live on Friday. So how that would work is you would get on Friday during either your regular class period. I'm going to set it up where I have one each class period, but I know second period, 8:30 is kind of early. So if you don't want to get up at 8:30 and you want to wait till third period to do it, and you have that option, then you can, but I don't want to force you to have to take it or have to do the quizzes live during a random or during your class period if you don't want to. So there'll be a quizzes for every single class period, but don't feel pressured to go to your specific one. but more information will be up on the video tomorrow for that. But that's my plan for the rest of the week. So for number 2 and 4 were just basic finding the area of composite functions, and then 6 and 8 were the shaded regions. So looking at number 2, I have what appears to be a full circle, which I'm going to say is like my figure 1. So 1 is a circle. And then my second figure is a parallelogram, okay? I know it's a parallelogram because I have 2 pairs of parallel lines. And then these diameters of the circle are actually going to be congruent on both sides, so they're going to have a set of congruent sides. With this parallelogram, I'm actually going to calculate its area second. So, because I think the circle is pretty easy, I'm given that the radius is 6 inches here. So for the area of a circle, and the reason why I'm not doing half of a circle is because I have 2 halves already, so that would just make a whole. So I'm going to take pi times r squared. In this case, my r is 6, so pi times 6 squared to give me 113.1. Okay. The next thing is to find the area of the parallelogram. Now, we're not told exactly what this length is of this base side, but it could be pretty easy to figure out because all the radius is an equal distance from the center of the circle to an edge or the circumference. So if this is 6 inches, this also has to be 6 inches over here. So I'm going to write that in. This is 6 inches, this would be 6, and this would be 6. So the length of this parallelogram would have to be 12 on both sides. Okay? So that makes my area a little easy. So the area of a parallelogram is just base times height. And my height is coming from this 5 inches here. There's those right angles and kind of finding the altitude of that parallelogram. So I'm going to have 12 times 5 to give me an area of 60. And then all I have to do is just add these together to get my total area. So 60 plus 113.1 gives me a grand total of 173.1 inches squared. Okay, so on your corrections, if this is one of the problems that you missed, you're just going to put your work exactly like this on a piece of paper. If you were able to print out the notes and you just want to put them on there, I'm cool with that as well. But just having it on a blank sheet of paper will work as well. If you're having to submit through Google Docs, I think I only have like 1 or 2 of you that are doing that. Just try your best to get these formulas as clean as possible. I know it's probably not as easy without just taking a picture of your handwriting. With number 4 kind of looks like an ice cream cone. I see 2 regions right away. I see this semicircle, and then I see a triangle. The semicircle is pretty easy to figure out. If I'm given that the diameter is 16, I have to take half of that diameter to find my radius. So half of 16 has to be 8. So the area of my circle is going to be 1/2 pi times r, which we said my radius would be 8 squared. Okay, and again, I only have half of a circle, so that's why I added the half in the very front. So 1/2 times pi times 8 squared would give me 100.53, and then we're in meters squared. Okay, so the next part is where it gets a little tricky with this triangle. So I'm given the base of the triangle. The base would be 16. That's the same as the diameter of the circle. But then I'm not actually given the height, okay? The height is always from the base of the triangle to the top of the triangle, and it has to form a perpendicular, has to form a right angle, or that has to be perpendicular to the base. So what I mean by that is typically we would have this dotted line drawn, and there would be a right angle here, okay? So since we don't know what the actual dotted line is, we have to figure it out. So I'm going to erase this real fast. And that. Okay, so looking at this right triangle here, I'm trying to figure out what this dotted line is. So again, I have a right triangle. If I just were to redraw that down here, this side is 8, this side is 17. I want to figure out what x is, that height. So I'm going to take 8 squared plus x squared and set it equal to 17 squared. To solve for x, I'm going to subtract 8 squared from 17 squared to get x squared is 225. Then I can take the square root of both sides to get x equals 15. Okay, so I know the height of this triangle is 15. So now I could easily put that into my formula for the area of a triangle. 1/2 base, which is 16, times the height, which we just found, is 15. And so the area equals 120. And the last thing I have to do is just add those two areas together, and I would get a total area of 220.53 and then meters squared. Okay, so 6 and 8 again were those shaded regions. So for number 6, the two shapes that I see are one, this looks to be like a square. The only reason why I know it's a square is because of this circle inside of it. And if you think about a circle, which this is why I didn't expect you guys to get these 100% correct, because we don't know everything about a circle. But from the center, a circle is equidistant on each side. Okay, so that's why this figure is a square. So right away, I could figure out what the entire area of this square is by just taking 25 times 25. And I get 625. So that's the overall area. Now I gotta figure out what is this circle area, and then I'm gonna have to subtract that white circle from the entire square area that I just found. So the circle is when it becomes a little tricky, because you really have to think about what does diameter and radius mean. So since this is a square, that means if I were to cut this circle in half, this length should also be 25. Okay, now if I bring that center piece right back. So then now I have to think about, okay, what's the radius of this circle? The radius is just half of the diameter. So what's half of 25? That has to be 12.5. So the radius of that circle is 12.5. So to find the area of the white circle, I'm going to take pi times 12.5 squared to get 490.87. And again, that little way to figure out what to subtract from what, always do subtract the smaller number from the bigger number. and that should make sense. I want to subtract the white area. The white area has to be the circle. So 625 minus 490.87 to get 134.13 feet squared. A lot of you actually figured this one out. And I think the Canvas thing, if you looked at your grade right after, it counted it wrong because you didn't put 0.13. I'm going to make sure and I go back and change that. So if you got 134.1, don't worry about redoing this problem because you really did get the right answer. So don't worry about that one. Okay, with number 8, I'm pretty sure I gave you this hint that this right here is a right angle in the video I posted yesterday, and since that is a right angle, that's what's going to help me figure out this distance, because what I'm highlighting is a right triangle. So if I were to draw that right triangle out again, it would look something like this if I flipped it. This would be 9 and this would be 21.6. And then that missing side, I'll call it X. Oh, sorry. That missing side is my hypotenuse in my triangle, but it's also the diameter of the circle. So once I find the diameter of the circle, that's going to help me to find the area of this half circle, which is a majority of that shaded region that I want. So I'm going to figure out what X is before I even think about finding the areas of any of the figures first. So if I take 9 squared plus 21.6 squared equals X squared, and I simplify those, I would get 547.6 equals X squared. And then take the square root of both sides to get X equals 23.4. Okay. The diameter of this circle is 23.4. Now I'm going to think about what is, if I were to draw the center point of the circle, what is half of that to find my radius? So 23.4 divided by 2 would give me a radius of 11.7. So my radius turns out to be 11.7. And so now I can find the area of that half circle. And again, it's a half circle, so I need to use 1/2 pi times r squared. So 11.7 squared. And the area of the half circle turns out to be 215.03. Now I need to figure out the triangle. So the triangle, I actually was given everything. Since this is a right angle, this 9 meters would be my base, and this 21.6 meters would be my height, because again, the base and the height are forming that right angle. So that's the two most important pieces when I'm thinking about the area of a triangle. So area of triangle equals 1/2 base times height. And so the area of the triangle turns out to be 97.2. Now I'm going to subtract the white area from the entire gray area, or so that I'm just left with the gray shaded area. So I'm going to take 215.03 minus 97.2 to get that shaded region, which would be 117.83 meters squared. Okay. Now I'm going to start some, I think these problems are a little bit easier, quite honestly. I think the ones from yesterday were quite challenging. So if you want more of like a confidence boost, I would try these. They're definitely going to be a little bit more, I wouldn't say easy, but they're more practical, I think. The other ones were just a little too challenging right off the bat. So looking at number 1, I have this kind of like oval, little like, I don't know, it's a weird looking shape. But right away I noticed that I have this half circle kind of cutting out the shaded region. And then I also have this other half circle over here, okay? If I were to like cut off this half circle, it would fit perfectly there, okay? And the reason why that's happening is because these half circles have the same diameter. So that means they have to have the same area. So I'm going to get rid of all my markings real fast. But I'm going to think about, okay, I'm not even going to worry about taking into account this missing area because it's right here. And if I also look at where I'm given, this is 20 millimeters, this is 20 millimeters. That means that this right here is a square, okay? All these side lengths are the same, so it has to be a square. So if I find the area of the square, it would be 20 times 20 to get 400. Now, I'm pretty much done because I don't even have to think about erasing this half circle, because if I erase that half circle, I would then have to add it back with this other half circle. That would be the same thing. So really, if I just think about cutting this half circle, that's still the shaded region, and just shifting it to fit this puzzle piece, I would just then be creating this square that I just found the area of. So this problem is done. So the area of this figure is just 400 millimeters squared. Okay, number 2 is not quite as easy as that one, but it's not as bad as the other ones. So in 2, I see 2 main figures that I want to use. I see this triangle, and it's actually an equilateral triangle, so that'll come in handy. And then I see a trapezoid. So right away, I see with the trapezoid, that I'm given both of the bases. So one base is 38 feet and the other base is 22 feet. I also see that I'm given the height. The height is coming from one of these sides in the equilateral triangle. And I'm told that this height is also going to be 22 feet. So I have everything to figure out what the area of the trapezoid is right off the bat. And so the area of a trapezoid is 1/2 the height, which is 22 feet, times the bases added together. So 22 plus 38. Okay. And doing all that math, the area of the green trapezoid is 660 feet squared. Now I just have to think about my equilateral triangle. So I'm actually going to draw it down here because I want to do a little bit more with it. So again, this is an equilateral triangle. I'm told that all these sides are the same length. And that's really helpful because I already know one of the sides is 22 feet. So really all of these sides are 22 feet. So I know the base. The base could be any of these sides. Get my pointer. The base could be any of these sides. I just need to figure out what the height is. So I'm going to draw in my altitude. Okay, there's my little right angle. So now I'm going to just think about one of these right triangles within that equilateral triangle. So I don't know what my height is. Let's actually call it H. I don't know what my height is. I know that one of these, my hypotenuse side, so if you're looking at this right triangle here, the hypotenuse side would be 22. And then I just need half of the base. I'm only wanting half of the base. So half of the base has to be 11. So this side down here is 11. So to figure out what h is, I would have 11 squared plus h squared, or x squared, however you want to think about it, equals 22 squared. Okay, so 11 squared is 121. 22 squared is 484. Subtract 121. And h squared is 363. Then take the square root. And so my height of that triangle has to be about 19.1. Okay? So my height is 19.1. And my base is 22. So now I have everything to figure out the area of the triangle. 1/2 times 19.1 times 22. And so the area of the triangle is 210.1. And last but not least, if I want to find the total height or total area, I would add those two together. So 660 plus 210.1 to get 870.1 feet. Squared. Alright, so for number 3 here, I have, kind of looks like a spaceship. I'm going to draw in this line right here. And voila, I have a half circle and I have a trapezoid. Okay, so with that half circle, starting out, the area of the half circle, I'm given that the diameter, so the length of halfway around the circle, is 9 meters. So if I need the radius, I'm going to take half of 9. So half of 9 has to be 4.5. And again, I'm only dealing with half of that circle, so I'm going to have 1/2 times pi times r squared. We said our radius would have to be 4.5. You don't want to use your diameter, okay? And so the area of that half circle turns out to be 31.8 meters squared. Now with my trapezoid, I'm given everything that I need. Here's one of my bases, it's 23 meters. My other base would just be the diameter of this half circle. So the diameter is 9 meters. So the other base would also be 9 meters. And then I'm given the actual height here with this 7 meters. So I'm just going to plug in everything to my formula. One half times the height times 9 plus 23. Okay, so my area of my trapezoid is in fact 112 meters squared. And now I'm just going to take both of these numbers, add them together to get the total area. So the total area of this spaceship looking figure is 143.8 meters squared. Okay, number 4 I think is a really good one as well. Right away, I'm just going to start looking for just different shapes. So right here I see a square. Okay, so area of a square. And that would just be 13 times 13, or 13 squared. So that area is 169. The next thing I see is this half circle. Okay. And the half circle has a height of 30. So that means its diameter is 30. So I want to think about what is the radius. And so that has to be half of 30, which is 15. So the area of half of a circle would have to be 1/2 pi times 15 squared. And that turns out to be 353.4. And the last thing that's remaining appears to be a trapezoid. Okay, and it looks like a trapezoid because I have these two sides look to be parallel to each other, and then it's actually an isosceles trapezoid because I have two sets of congruent sides. But I know what both of these sides would be. This one is a part of that square, so that side, that base is 13, and then my diameter of the circle is making up that other base, which would be 30. And then I'm actually also given the height of the trapezoid right here with this 20 inches. So I have everything I need to calculate the area of this trapezoid. So 1/2 times the height. The height is 20 times the bases added together, 13 plus 30. And that area turns out to be 430. And the last thing I need to do is just add these together. So 169 plus 353 plus 430, and I get 952.4 inches squared. Okay, this last problem is one that I have seen on a lot of standardized tests. It's probably one of your most basic word shadow shaded problems. Typically you see a lot of landscaping problems with these. So it says, one of the displays at a botanical garden is a koi pond with a walkway around it. The figure shows the dimensions of the pond and the walkway. So I'm told there's a pond and then there's a walkway around it. So this inner circle is, I'm guessing, the pond. Okay. And then around it would be the walkway. So part A asked me to find the area of the pond to the nearest 10th. So I'm not even going to think about this area outside. I'm just going to think about this blue shaded region. So within this blue shaded region, I'm going to kind of draw it again. Ah, that's really bad. Okay, I have this kind of like oval looking thing, right? I'm given that this length right here is 13. And then the diameter of the circle that hopefully you see is forming is 7, okay? So I'm going to split this up because what I see is a rectangle that is 13 by 7 and then two half circles that have a diameter of 7. Sorry, this drawing is really bad. Maybe if I zoom in. So there's one of the half circles, and then there's another. So if I put those two half circles together, I would have one full circle with a diameter of 7. Okay, so when I find the area of the pond, I'm going to have the area of the rectangle plus the area of the circle. Okay, the circle again is coming from the two half circles on the edge of this pond. So the area of the rectangle is going to be 13 times 7, which turns out to be 91. And then the area of the circle, I need the radius, so half of 7 would be my radius. So half of 7 divided by 2, is 3.5. So my area would be, and I need a full circle because I have 2 halves, would be pi times 3.5 squared. Okay, so that area turns out to be 38.5. Okay, so if I add these two numbers together, that's going to give me the total area of that koi pond, which would be 129.5 feet squared. Okay, part B is to find the area of the walkway to the nearest 10th. So the walkway is this outside area, and I'm given some new dimensions, but it looks like the same shape. So since it looks like the same shape, I'm probably going to have the same type of procedure. So again, let me try to draw this down here. Well, that wasn't bad. And I'm given that from here to here is 35 feet. And then from here to here is 15. So already I see that rectangle again right here. And then I see 2 half circles there and there. Okay. So if I think about just the rectangle now is going to be 35 by 15 for its dimensions, but the circle is going to have a diameter of 15 now instead of 7. So I'm going to do the same thing. I'm going to have the area of the rectangle be 35 times 15 to get 525, and then the area of the circle is pi times r squared. So now I got to think about what's half of 15 to get my radius. So half of 15 is 7.5. So pi times 7.5 squared to get my area of 176.71. So now think back to the problem. I just want this outer ring of the koi pond, okay? So I have to, if I find this entire area, at the very end I'm going to have to take away the koi pond because that's not part of the walkway, okay? That's just like the center part. So if I add these 2 areas that I just found together, that would give me this total area, and then I'm going to have to subtract that area of the koi pond at the very end to find just the walkway. So the total area is going to be 701.71, and then I'm going to subtract the koi pond. So the koi pond was 129.5. And so the total area of the walkway turned out to be 572.2 feet squared. Okay, so I know that was a lot as well. Make sure you have 2, 4, 6, and 8 done, and that you have at least attempted these other 5 problems that I did today, especially number 5. I think number 5 is probably my favorite out of all of these 5, and number 4. So tomorrow we're gonna do even more practice again, and then on Friday, like I said, we're gonna have that quizzes. Whatever your score is on that quizzes, that's going to be your score for the day. So this is not a quizzes that you're just going to join and try to guess C every single time. I actually want you to do well, and the purpose of doing all these problems now is so that you do well in that quizzes on Friday. Okay, so prepare as much as you need to. Again, I'm here to help, but I will talk to you later, guys.